Hello everyone and welcome back. In the era of vibe coding, when practically anybody can create the application from scratch using ChatGPT or AI, for example, it is more than ever important to come back to the solid foundation and principles of data and databases. There are good reasons for doing so, but before I talk about databases as my interest as a data scientist, I want to bring up the topic of the vibe coding itself. Disclaimer, I'm not against. I think it's really amazing that we are living in this era right now when the AI can help us in so many ways, right? But when you and others create the application within a couple of days or a week, and basically using AI as your assistant or solely by using AI, there are two things that will define whether your application will sync or scale. One is the graphical design, which we will not talk about in this video because it's not about that, but essentially if no one finds your app attractive as the users, customers, if the graphical design or user interface are not intuitive enough, then no one will actually use your app, right? And they would go to your competitor, for example. That aside, even if you have customers and your app gains traction and increases the number of customers, how would you scale the underlying databases? So that brings me to the topic of today's video, where I want to talk about this. As they say, the data is the new currency in the digital world. And if your application, even if it looks great from outside, if the underlying data is not well thought and the database is designed poorly, this will inevitably negatively affect the performance of your application and user experience by increasing the load times. If you have been following me either from my online articles on Medium or here on YouTube, you know that I strongly advocate for solid and strong foundation. And if you can couple this knowledge with the advances in technology, artificial intelligence, and LLMs, practically become unstoppable. Alright, that's enough of the introduction. Let's dive into the practical tutorial on the database 101 in the era of vibe coding. Very briefly, let us revisit some of the important concepts and terminology related to the data and databases. So if you are familiar with all of this, you are free to skip to the next section, but I would recommend you staying up for a couple of more minutes to freshen up these concepts. So when we talk about database, what do we mean? Put simply, a database is the organized collection of data. I'm just taking a peek into my notes here. And how do we access this organized collection of data? To access them, we use queries. What is a query? A query is a way to interact with the database. The language we use to write this query is called a structured query language, or in short, SQL or SQL. If you are new to my channel, check out my SQL playlist with all of the tips and tricks that I'm sharing, how you can level up your SQL game from being a junior to senior data scientist. Next, what is a table? A database is the collection of related tables. Table is a structured way to store data, organized into rows and columns. Each table stores data about the particular subject. For example, it can be a particular product, a user, customer, and so on. Columns of the table represent the fields or subject attributes, such as if it is a user or a customer, it can be first, last name, date of birth, address. If it is a product, it can be attribute, can be, if it is, for example, a chair, attribute can be a chair color, price, material, and so on. While the rows of the table represent the different records or so-called entities of that subject. For example, if it is a user, it can be user 1, user 2, user 3, and so on. And for products, it can be maybe a chair, table, shelf, and so on. Here you can see an example of the table called users with a couple of only 2 columns attributes. The ID, which you will see will be the primary key, which is really the essential part of the every table, is to have a unique identifier for each entity. And it has a first name, which is, in this case, it has a type of string. And entities are John Doe, Mike Public, Alex Green, just some imaginary names. This is the basic idea behind the data stored and accessed in the databases. There is a more advanced concept I don't want to talk about in this video, otherwise it will be too long, but it's called database schema. I am going to talk about this in more detail and how you can design your schema in the future videos, so subscribe to my channel to stay up to date. But essentially, you can define schema as the blueprint that outlines the structure and organization of a dataset. Alright, it's time to jump into the pgAdmin 4, the database management system, for our hands-on tutorial. You can see here the interface of pgAdmin 4, and if you are not familiar with this, please check out my previous videos where I explained how to use it. But essentially, see on the left panel, on the top level we have servers. I created a server called my local server, and it has 2 databases. One standard database, which is called Postgres, which comes out of the box, and another that I just created is called database tutorial, specifically for this case. If you want to create your own database, just right click of your mouse or touchpad, place create database, and then you can specify parameters like the name, different IDs, and then you will see, for example, show you an example name, SQL. It will create a database using this SQL command. I will not create it, changes will be lost, yes, because I already have it. And then if you navigate to schema, public, you can see tables and stored procedures. These are essentially 2 parts that I covered in the previous section, but as of now, even if I click and refresh, you will see that we don't have any tables here. So let us create our first table for first example to warm up a little bit. Again, if you are familiar with these basics, you are free to skip to the next place where I explain the real life but simplified example of database with multiple tables, where I tell about one-to-many and many-to-many relationships and how you can program that. So here we are creating a table called users with the following columns, attributes. One you can see is called ID, which can be either serial or integer, for example, and it will be primary key, so it cannot be null and should always be present and be unique key for each specific entity. We have a name of the user, which is essentially a text, which is varchar, variable character of the length 50, which is not null, because we want users to have a name. It cannot be null, which is empty value. And the length of this column is 50 symbols. If the name is longer than 50 symbols, it will throw an error. You can remove this part if you want, but I would keep, assuming that there are no names longer than that, as an example. One tip that I wanted to point out here already is to have 2 columns, which are called created at and updated at, or create DT, datetime, and update DT, update datetime, or however you want to call it. But essentially this will be either timestamps, or you can use string if you want for text format, or is it text, I think, yeah. So we also want to place default as a current timestamp. This syntax places default value if it is not provided of the today date. You will see that in a couple of seconds that today we have July 16th of 2025. So if I run this command, we see that they create table, query returned successful, which means we created a table. You cannot see it here because you need to refresh, and boom, here you have users table. You can check out the columns, its schema if you want, and so on. But now our table right now is empty. So we use this syntax and we want to insert some data to have a quick short practice here. As an example, let's insert two values called John Doe and Mark Public. If you see that I have these two comments separated by semicolon, which is important to separate, to end specific command in SQL. And if I run it, will run into the error because users already exist, because I'm rerunning the command to create a table, but that table already exists. So we can either comment it out, or we can put another additional clause which is called create table if not exists. And then if this table does not exist, create table. So it already exists, so it will not create this and move to the next clauses. Let's run it. It should return success. Notice relation users already exists, skipping. All right, okay. We need to provide the ID, right? I told about this. If it is serial, I think it should be populated on its own, but if it's not, let's make ID 1 and ID 2. And now let's rerun it. Query return successful, insert 0, 1. All right. Now we want to comment this out because we don't want it, and let's quickly check, do sanity check. Simple select all. As I mentioned in previous video, it's really important to not use select star in production codes, but this is a very small simple example, and we know that we are just doing some testings and sanity checks, so it's all right to do it. But in general, it's important to write every single column you want to query, right? That's the idea behind this. But we will select all columns from table users, where name mark public, specifically one entity. You see that it was created on July 16, 2025 at this time. It's the current time. If I don't use this, it will select all the users, which should give us John Doe and Mark Public. Exactly, yeah. So it's all good. Now we know how to create a table in the database, how to insert a few values, and how to query that data. Now let's go step by step. Now, if there was a mistake or you want to do some additions to your entities, you can use the following syntax, which is called update table name, set name equal to which name you want to set, and you choose, for example, which entity you want to change. So let's change Mark Public into Mickey Mouse, a funny example that I came up with. Let's run this, and then we can run this query. Oh, it's already here. Yeah, I already put some examples beforehand. We will run two commands at the same time to save time, and you can see John Doe became Mickey Mouse. So that's how you can update a table, update a given entity. If you want to remove a table, for example, a real world example, if you want to delete an entity, for example, a user or a customer who uninstalled our application and opted for erasing their data. So we want to delete their data. In real world, in practice, we want to delete only personal data and keep anonymized, aggregated level data about that customer, which we can use in the future, for example, for training machine learning models, for predictive modeling or risk analysis and so on. But that's all outside of this tutorial. So let's see how this will work out. The syntax for this is delete from users, where name, instead of equal to specific name, it has a like join with this percentage sign. It's a wildcard that selects, matches every word before and after John. So in this case, it will be only John Doe because you have only 2 entries. But it should remove it. Let's quickly run it. You can see successful run and we can see only 1 entry. Nice, that's how we can remove data. And finally, let us delete this table to complete this first quick example. To do this, you simply write drop table, table name, in this case users. Boom, drop table, successful. If we refresh, you will see no tables here, which is great, right? That's what we wanted. Now let us move to another example, which is a bit more complex, but I will try to build it step by step, so you will see how you can design a more complex and somewhat more like a real world database. So let's see how it goes. For this second example, we will be creating the library database. So as a use case, for example, let us think about the public libraries. This will include the following information. Information about the available books stored in the library collection, the names of the authors who wrote those books, and for example the visitors who can visit, read the books and borrow them home. And we will see how we can design the database that will relate all of these quantities. Again, step by step, let's handle this in the simple manner and jump back to the pgAdmin form. But before that, just a quick note. So I created a couple of assumptions regarding the relationships between these subjects. So assumption 1 is each author may have 1 or more books, and assumption 2, each book has only 1 author. For this simplification, there are no books written by multiple co-authors. So 1 book relates to 1 author, but 1 author relates to multiple books. In this case, this is called a one-to-many relationship, or if you flip it, many-to-one, however you like to call it. So let's start by creating the table authors and books and see how it goes from there.